Welcome everyone to our video about motion. So this is just where we're going to introduce motion, nothing too crazy, but we just got to lay some groundwork so when we are back in person, we kind of can move on from here. So physics stuff, motion. So when we talk about motion, we really have to introduce these types of measurements. So we've already talked about measurement in terms of like meters and inches and stuff, but what we are going to begin talking about are scalar quantities and vector quantities. So there are two basic types. And the thing when we talk about scalar quantities, this is something that it's a number, it's a magnitude, it's how big, but that's all it is. So a scalar quantity is simply like, it's a number, or we could say it's how big, or we could say it's a magnitude. Okay, now if any of you have watched the movie Despicable Me, Vector goes and he's applying for a new villain loan, and he's committing, his name is Vector because he's committing crime with both direction and magnitude. Oh yeah! But the idea of a vector quantity is it has, Vector is committing crime with both direction and magnitude. Okay, so the idea of scalar versus vector, when we talk about scalar quantities, it's really just a magnitude, where when we talk about vector quantities, it has to have a direction associated with it. So some classic examples are time, distance, and speed. Those are scalar quantities, whereas vector quantities are something that we refer to as displacement, velocity, and then acceleration. These two go together, distance and displacement. Yeah. And then speed and velocity are also like complements, I guess is probably the better term we should be using. So time is scalar, but really it's just a measure of a duration of something, but in the units we're going to be using is seconds. Now realize there are other things we could use, and the units we use for seconds is simply the letter S. So when we do our calculations, we want time in seconds. Could you measure in hours, days, weeks? Yep, you could. But for our calculations in motion, we want seconds. But it's a scalar quantity. There's no such thing as a negative time. It's just simply a number, a magnitude. So distance and displacement, like I said, were complements of one another. So when we talk about complements, they kind of approach the same thing, but they have one scalar, one's a vector quantity. So the questions that we can kind of ask ourselves in order to determine distance is how far did I, oops, this should be, sorry about that. How far did I go? Not how far did I do? How far did I go? Whereas displacement, how far am I from my starting point? Or sometimes there's kind of the classic like words of like, as a crow flies, and I'll kind of talk you through that. So in some of these examples of how far did I go, if we go through and we say that I were to go and I walk for 4 meters, that's my unit of measure, and then I stop and I take a break, and then I go and I walk another 4 meters, we could say, well, what was the distance that I traveled? And in this case, you would say that the distance traveled was 8 meters, right? You simply go 4 plus 4 is 8. How far did I go? I walked 8 meters. But when we talk about displacement, what we're saying is how far am I from my starting point? So the idea is if this is my starting point right here, and this is my end point represented by the arrows, we have to then figure out how far did we physically go. In this particular case, if I start here and I walk 4, I stop and take a break and I walk another 4, how far am I from my starting location? In this situation, I'm also 8 meters to the right. We need a direction now associated with my displacement. Okay, we can do it with an arrow, or we can simply say to the right. In this situation, I have this. I have vectors, arrows again drawn. So if I were to go through and I start here, and I walk 4 meters, and I stop and I walk backwards 3. When we say how far did I travel, in this situation, I am 7 meters. I've walked 7 meters. But when we say how far am I, I'm right here, how far am I from my starting point? Now I'm pretending that I walked in a straight line here. How far am I from my starting point? I am 1 meter to the right from where I started. We need that direction. Okay, so I walked a total over 4, back 3. I walked a total of 7 meters. However, I'm only 1 meter to the right of my starting location, so they're slightly different. If I go through and we say, hey, I walked 3 meters, then I turn 90 degrees, and then I walk 4 meters this way. When we say, well, how far did I walk? The answer is my distance is going to be 7 meters. Now, in this situation, how far am I from my starting point? Well, I'm here. So how far am I from here? Well, this happens to be a special right triangle. So it's a 3, 4, 5. And this is a trig function that I'm just showing you. But so how far is my displacement? I'm 5 meters. And then we would have to give a direction. And this one gets a little bit more complicated about what is the direction, because then we have to do some trig functions to determine the arrow. But that's the idea, is that we would have to include some type of direction associated with it. The last example I want to go through for distance and displacement is this one that often kind of messes with people and say, well, how far did I walk? Well, I walked 4 to the right and I walked 4 to the left. Well, distance walked, that one's pretty easy. I walked 8 meters. But when we get to the idea of displacement, again, how far am I from my starting point? The idea is I'm going to start here, I'm going to walk 4 meters to the right, and I'm going to stop, and I'm going to turn around, and I'm going to walk another 4 meters back. In this case, the displacement, how far am I from where I started? The answer is I'm at my starting point. I haven't gone anywhere in terms of displacement. My displacement is 0 because I'm back at the original starting point. And that's an important definition that we'll kind of come back to and revisit. So that's distance and displacement. The complements of speed and velocity are kind of one and the same as well. So the idea is speed is scalar, velocity is a vector. Speed is the measure of how fast we're moving. So a lot of times when we talk about speed, we'll say 55 miles per hour, or we can say 10 meters per second. That's what we use in science classes, or in physics. We could say 25 meters per second. But now when we talk about velocity, velocity is speed and the direction. So now we need things like 55 miles per hour east, or I need 10 meters per second to the right, or I need 25 meters per second down. We need a direction associated with it. Now, in order to determine speed or velocity, we can use this generic equation. V average is equal to delta x divided by t, where V average either represents speed or it represents velocity. Now, how do you know which one it is? How do I know if I'm calculating speed, or how do I know if I'm calculating velocity? And it goes back to this piece, and this piece represents distance and displacement. If we are using displacement, that's a vector quantity, then we're going to be calculating velocity. However, if this delta x is distance, which is a scalar quantity, then V average will represent speed. And we'll walk you through a couple examples there. So the idea is, how fast am I moving? Here's the same arrows that we drew before. So if my delta x, the distance, this is distance because I'm in the scalar quantity, right? This is meant to be kind of like sections. Okay, so we're using the same arrows. But if I walk a total of 8 meters, and my time is 10 seconds, I can go and say, well, 8 meters divided by 10 seconds is going to be 8 divided by 10, and our units are going to be 8.8 meters per second. That's my speed. Now over here, this delta x, because we're talking about vectors, is displacement. So this is still the same equation. It's still 8 divided by 10. My magnitude, the number, is still 0.8 meters per second, but now I need the direction of to the right. I need a direction to calculate velocity. So for this one, same idea. We can go through and say, well, my distance was 7. How far did I walk? I walked 7 meters, so we can say 7 divided by 10 is 0.7 meters per second. That's my speed. But if we're talking about velocity, my displacement is only 1 meter, and I should have, and I messed this up, and I apologize. It should be that I'm 1 meter to the right of my starting location. How far am I from my starting location? I'm 1 meter to the right. So when I go through and I say 1 divided by 10, the magnitude is 0.1 meters per second to the right. I need the direction to go along with my velocity. This was a special right triangle. How far am I? Well, this was a 5 meters, but in terms of calculating speed, it's 7 divided by 10, 0.7 meters per second. But then when I go through and I calculate my velocity, it's going to be my displacement. How far am I from my starting location? And my displacement was 5. So then we can just say, hey, well, that was 0.5 meters per second. And I'm just going to say with a direction, because I would need to add a direction to that. But like I said, this one gets a little complicated, and I can't actually finish writing the word direction. Okay. So this is not a trick question, but the idea is the average speed, because I walked a total of 8 meters, is going to be simply 8.8 meters per second. But how far am I from my starting location when I end at the same starting location? It's 0. So my average velocity is 0 meters per second. I'm back to that starting point. Okay, one last definition that I want to make sure we're kind of clear on, and we'll come back to in the next couple days, is this idea of acceleration. It was also a vector quantity from our list. By definition, it's a change in velocity. But the thing about velocity is, if we talk about velocity, well, velocity is a speed or direction, or speed with direction, right? So if we could say that an acceleration is a change in velocity, instead of saying velocity, we could say it's a change in speed, or we could say it's a change in velocity. So if I change my speed, I'm accelerating. I step on the gas pedal. I step on the brake pedal. That's changing my speed. That's an acceleration. That's an obvious one. The thing that we often forget is when we accelerate, we're changing our direction. We could change our direction. So if I turn the steering wheel, I change the direction, therefore I'm accelerating. We feel accelerations in our car. It's what pushes us forward, backwards, left and right. Step on the brake, you go forward. You step on the gas hard, you go backwards. You turn the steering wheel, you get pushed to one side or the other. We feel accelerations. So if we change our speed or we change our direction, we are accelerating. Kind of last one thing, when we talk about average speed is really just an overall picture of our trip. Okay, so when we say it's how far did we go in a given amount of time, it's kind of this, it's an average, and that's exactly what it is meant. So the example I like to use is there's this like unofficial race that they call, and it's called the Cannonball Run. There was a film in 1981 with Burt Reynolds that talked about this race, and it's this race across the United States that starts in New York and it ends in Los Angeles. It's about 2,803 miles. And the original, it originally happened in like 1970 something. This Cannonball Run started, and it was kind of a protest to the speed limit of the national speed limit of 55 miles per hour. And they're like, you can't tell us, this is stupid. The government can't do this. This is a mandated thing. We shouldn't be limited to this. And it's during the gas crisis. That's why they set it to 55. They were really limited on gas. So this group kind of organized this, and ever since then, it's kind of been this thing and kind of a following of certain groups. Well, just last November, I believe it was, in 2019, there was a new record that was set where a group of people went from New York City to LA, 2,800 miles, in about 27 hours, or in 27 hours and 25 minutes. So their average speed for if you take this and you divide by the total time, was around 102, 103 miles per hour. Now that doesn't mean they were going 102 miles per hour. That was their average speed. Okay, that was their average speed. So at some points, they claimed they reached a max speed of 193 miles per hour. But at some point, they had to stop for gas. I think they stopped like 3 times to fill up with gas. They had to add a couple extra gas tanks to it. But it doesn't mean they were going their average speed the whole time. If you go to Madison, you might average 60 miles per hour. but you might get behind a slow car. You might go faster than that. You maybe have to stop to go to the bathroom or stop for gas. This average speed is for your whole distance divided by your time. So slightly misleading. It's an average speed compared to another thing we'll be getting to is something called instantaneous speed. So how fast are you going in this instant in time? Okay, disclaimer, don't try the cannonball run at home. Going 193 miles per hour is not safe. Averaging your speed of 102 miles per hour is not safe. Do not try this at home. Have a great day, everyone.